Hi, I'm Katelyn Beenken, and I'm going to be talking about the seasons. So the tilt of the axis causes the Earth's seasons. As the Earth revolves around the sun, the tilt stays the same at 23.5 degrees. As the Earth is tilted on its axis, it revolves around the sun. It causes two things to impact the seasons: the direct versus indirect rays and the length of the day. So when the sun's rays are the most direct, it makes the seasons warmer. When the sun's rays are the least direct, it is the coldest time. This is because when the sun is most directly over top of us, more of the sun's energy reaches that area. In this diagram, the sun's rays are the most direct in the southern hemisphere, and they are much less direct in the northern hemisphere. When the sun is directly over top of the southern hemisphere, at the equinox, the sun will be directly over the Tropic of Capricorn, northern hemisphere while in the northern hemisphere, the rays are at more of an angle as the tilt of the Earth makes the sun rays also at more of an angle. This means that the sun's rays are indirect in the northern hemisphere. So this diagram is the opposite of the previous one, where now the Earth is tilted so the northern hemisphere is tilted towards the sun. This results in the northern hemisphere getting the most direct sun rays. During the times of the most direct sun rays are when we have the summer season, and the least direct times are during the winter season. So when this hemisphere is tilted toward its summer, and when it's away, it's winter. In this diagram, it shows the seasons in the northern hemisphere. Between the winter solstice and the summer solstice, the days get longer. On June 21st, the summer solstice, the northern hemisphere has the longest day. Between the summer solstice and the winter solstice, the days get shorter. On December 21st, the winter solstice, it is the shortest day. The seasons are the opposite in the southern hemisphere compared to the northern hemisphere. So where in the previous slide, it was the summer was, so when the northern hemisphere has summer, the southern hemisphere has winter, and likewise for the rest of the seasons. So during the equinox, everywhere has about 12 hours of daylight and 12 hours of night. This is the only time that both hemispheres have about the same length of day. The sun is directly over the equator during this time. Between the spring and fall equinox, the sun never sets in the Arctic Circle, which is the area above 66 degrees north. And likewise to this, during the fall equinox to the spring equinox opposite time, the sun never sets the sun never sets in the southern hemisphere or in the southern Antarctic Circle, which is below 66 degrees south. So the sun rises but never sets until the next equinox. But when it's not above the horizon, it doesn't rise for the next 6 months. So in conclusion, the tilt of the axis causes the Earth's seasons. As the Earth revolves around the sun counterclockwise, the tilt stays the same at 23.5 degrees. As the Earth is tilted on its axis, it revolves around the sun. It causes two things to impact the seasons. First, the direct versus indirect rays, which is how much the intensity of the rays and the angle that it reaches the location, and the length of the day, which is dependent on the number of hours the sun is present in that area.